Oh, welcome back. We're going to continue our discussion of radians, and then we're going to add this thing called coterminal angles. Coterminal angles. Now, if you saw my other tutorial, one of the key things when you talk about radians is you have to understand that when you find a radian, all right, and let me get my circle out here. A radian is essentially, once again, all right, the arc length around a unit circle. All right, a unit circle. Now, a unit circle, once again, is when we have a radius of 1. Okay, so radius of 1, that's our unit circle. All right, just keep on reviewing that unit circle. Now, with that, we can identify that around the whole entire circle, so 360 degrees, we know it's going to equal, all right, so 360 degrees, all right, we know in radians is going to equal 2 pi because that's the circumference of the circle. So this is 2 pi radians. And from here, we can then identify, which is my key thing that I always remember, is that from here, all right, and when you cut the circle in half, because it's the main thing they want to know, is that from 0 to 180 degrees, all right, that is equal to half of 360, so that's going to equal pi radians. And pi radians essentially is finding, yes, in a unit circle, this is that length around here. So this length right here, all right, from 0 to here, that radian measure is pi. 180 is equal to pi. All right, so when you have this, and let's just say we have our 1 radian, okay, and we did this little conversion last time, but just to make sure we know how to do it, because I haven't. But if I want to find 1 radian, what is 1 radian equivalent to? Well, we can set up a proportion knowing that pi is equal to 180 degrees. Okay, pi radians is equal to 180 degrees. Well, if we have 1 radian, I want to figure out what is that in degrees. I'm going to just put an angle theta for degree. Okay, we're going to solve for this right here. So what I'm going to do is I'm going to cross multiply. So I have pi, or this degree measure times pi. I have 180, all right, times 1 divided by pi. So we know that this angle in degrees, so 1 radian is going to equal 180 divided by pi. Now, if you want to do that, take your little calculator right here, and let's take 180, and we'll divide that by pi. And pi is right there. And what we have is, da-da-da, is about 57.3 degrees. All right, so about 57.3 degrees. All right, so we'll put that in there, 57.3 degrees. And that is actually equivalent to 1 radian measure. Okay, so it's just under 60 degrees is 1 radian. So as you're going around, you can kind of say, okay, this is like 60, so we'll just go right here. This is about 1 radian. And if you had another 60, all right, or 57.3, you get another, all right, 2 radians. So that's probably way too big. All right, but then we'd have 2 radians would be from here to here. So this is where the angle of 2 radians would be. All right, 2 radians would be that right there. And then if you go another one, all right, just under 60, so it'd probably be right about there. Once again, this is not totally thing, but this would be 3 radians, and so on and so forth. And you want to keep on going around. You can actually go around right here. This would be 4 radians. All right, and then you go there. It's probably be just past right there. It'd be 5 radians. All right, and oh man, all right, we got 6 radians. And just to make sure I'm not totally screwing this up, times 6. Yep. And if we go a little bit past that, that's probably going to get past what we have. So we're about 6 radians, and that's probably what you have. So not uniform, not exact, but that's what we got. Now, what I want to talk about is that's how, once again, reviewing how we find radians. Okay, but how do we find this thing called coterminal? Coterminal. Now, I didn't talk about this in the previous one, but a terminal side is actually the side of this right here. So if I have this right there, all right, this is my terminal side, and this is my standard, all right, initial side. And what we have is when we have create coterminal angles, is these are angles that share the same terminal side. And this is what's called a terminal side of an angle. All right, that's the terminal side, all right, of an angle, okay? And what we have is this right here is known as the standard position. All right, then this is the initial side of the angle. All right, we have that. Okay, now we talk about coterminal. Well, right here we know this is 1 radian. Well, if we wanted to go here, what we'd do is that if I want to find another one, what I can do is I can go all the way around a circle, all right, 360 degrees or 2 pi, and I come to this, all right, angle again, correct? And if I do it again, I can keep on going around again and again and again. And what coterminal means is an angle that shares the same terminal side. So how can you find terminal angles? Well, essentially, if you're given an angle, if you would add, all right, 360 degrees, if you're given this angle in degrees, or if you take this angle and you can subtract. Now, if you're wondering, how can you subtract? Well, subtracting from an angle means you're going the opposite direction. All right, so a negative 360 degrees would mean you're going the opposite direction. All right, you're going clockwise. All right, counterclockwise is how we always do in standard position of how we draw our different angles. Starting here at 0, we always go counterclockwise when we do our angles. So here is how we would find, and we would go n number of times, n being any integer, and we would do that n number of times around to get a bunch of different angles that are coterminal to this angle that we're starting with. In the same manner, if you had this angle, and this is when it's in degrees. A lot of different colors here. All right, but if you had radians, okay, we would do the same thing. Okay, same thing. We would take our angle. Remember, this is in radians, and instead of adding 360, we have to add in radian. We're going to add 2 pi. And if we wanted to go the other way, we could, or what we could do is we could actually this and take it, all right, subtract 2 pi from here. And we would do that n times, depending on however many times we have, n being any integer. We multiply that, and that would give us our coterminal angles. All right, and that's all we do. So if I had a radian of 1, and I want to figure out a terminal angle of that, I could actually take 1 plus 2 pi, and that would be a coterminal angle to the angle measure of 1, radian of 1. Okay, and I would just keep on going around. I could add another. All right, what's another one? Well, another coterminal angle, and you could have an infinite amount of these. I could take 1 minus 2 pi. That would be another coterminal. All right, these would be coterminal to a angle of 1 radian. Sorry, that's right. And I could go like this, and I could actually go and take 1. If I want to add another one plus, let's go and add another 2, so it would be 4 pi's. All right, so that means I'm going around this circle twice. Or I could subtract 4 pi. All right, and I could subtract 4 pi. That means I'm going around the circle the other way 2 times. And I would keep on going this in perpetuity. All right, just keep on going through and keep on adding 360 degrees or subtracting 360 degrees to get ourselves a bunch of coterminal angles. And that's it. So coterminal angles are angles that use or share, all right, this coterminal or this terminal side right there. And I have to get a different angle right there. And that's what we have right there. That's how we can get that. Okay. So with that, we know how to find radians. We know how to find coterminal angles. So I hope this helps you out and how to do some of your other great trigonometric problems. All right. So good luck and God bless.